If two lines are parallel, they are going to have the exact same slope. If the lines are perpendicular, they'll have opposite reciprocal slopes. And if the lines are coinciding, that means they're the exact same line, so they have the same slope and the same y-intercept. They might look a little bit different, like in the example here. This line is in slope-intercept form, and this line is in standard form, but if you rearrange the terms, they would be the exact same line, especially if I fix the typo and make that a negative. They would be the exact same line. When you're looking at the equation of a line, if it's in slope-intercept form already, remember you can see the slope just as the coefficient of the x term. If the line is in standard form, you cannot see the slope just by looking at it. The slope is not just 2, it's not just 1, and it's not 4. To figure out the slope, if the line is written in standard form, you need to change it, rewrite it in y equals form, and then you'll know what the slope is. If we want a perpendicular bisector of a line segment with endpoints 3, 4, and 11, 18, we're going to use both parts of that word. First of all, perpendicular, so we're going to use opposite reciprocal slopes. And then bisector, we're going to cut it right in half. To cut it right in half, I'm going to need to find the midpoint. And to find the midpoint, I'm going to add the x's together and divide by 2, and add the y's together and divide by 2. So the midpoint of this segment will be at 7, 11. That's going to be a point that is on our line that we want to write. And if it's going to be a perpendicular bisector, we've got to figure out the slope of the line segment that they gave us using y minus y over x minus x. So the slope of the line segment right now is 7 over 4. Since we want to be perpendicular to that, we want to use the opposite reciprocal slope, or negative 4 over 7. Using negative 4 over 7 as a slope and the points 7, 11, we can plug those things into y equals mx plus b and solve for b to write an equation of the line. The y number is 11, the slope is negative 4 over 7, x is 7, and then we have the b. Remember, 7 is like 7 over 1, so when we multiply, we just get negative 4 plus b, making the y-intercept 15. The equation for this line will be y equals negative 4 over 7x plus 15. Another example is write the standard form of the equation of a line that's perpendicular to that and passes through the point 0, negative 3. This is a great example of how I cannot look at this equation right now and tell you what the slope is. I'm not going to know what the slope of that line is until I change it to y equals form. This one's pretty easy to change to y equals form. Y equals 2x plus 6. So the slope of this line, exactly how it looks right now, is 2. Since I'm trying to write the equation of a line that's perpendicular to that, I want to use the opposite reciprocal slope, or negative 1/2. I'll use that slope along with the point that they gave and plug it into y equals mx plus b to start with. That's not what my final answer will look like. My final answer is going to be in standard form, but this will give me somewhere to start. Y equals mx plus b reveals right away that the y-intercept is negative 3. And maybe we could have figured that out from the beginning, because 0, negative 3 is right on the y-axis. So plugging in the slope and the y-intercept, we can see right away that the equation is y equals negative 1/2 x minus 3. I need to change that into standard form. So I need to get rid of the fraction. I'm going to multiply both sides by 2. And actually, I also want to get rid of the negative, so I'm going to multiply both sides by negative 2. Then I also need to get the x's and y's on the same side of the equation. And the constant on the other side. Now we have the equation of a line that is perpendicular to the given line and goes through the point 0, -3.